Science Beetle.
Hey, welcome back, students. As promised, this lesson is going to be entirely focused in calculating the number of neutrons and electrons for various elements. And so let's go ahead and dive right in. Let's say that we have a element, and just going to give you some information. So let's say you've got this element here. You know that its symbol is this one here, and it has a mass of, let's see, 12.011. And it's got a atomic number of 6. And the question for you is going to be, how many neutrons does this particular element have? And so in order to begin this, you got to recall the equation that we use to calculate the number of neutrons. So essentially we've got to take this number here, and we've got to take this number here. The top number, again, just to remind you, is going to be the atomic number. Okay? And the bottom number here is going to be the mass number. And the general formula is going to be that we're going to take the mass number, and then we're going to subtract from it the atomic number. And our resulting number should be the number of neutrons that we're looking for. Okay? So if we go ahead and do this and substitute the numbers, if we take the mass number here to kind of just plug it in, if we take the mass number here and we put 12.011 and we subtract the atomic number, in this particular case, is 6. The number of neutrons, if we do this right, is going to be 6.011, or a number of 6. So in this particular answer, the number of neutrons that we're looking for is going to be 6. Now, the next step in doing this is that you need to be able to draw the diagram. And so once we've calculated the information here, let's go ahead and draw the structure for this particular atom that we've got here. And if you haven't already figured out, this atom here is going to be carbon. And so we need to figure out, how do we draw the carbon atom? Well, since we know that the atomic number up here is also the same thing as the number of protons, right? So we're going to take and we're going to draw 6 protons, and we're going to color those in red. 1, 2, 3, 4, 5, 6. And then we're going to take the number of neutrons that we just calculated here at the bottom, and we're going to put 6 neutrons. 1, 2, 3, 4, 5, 6. Now, if you recall from last lesson, the way that we figured out how many electrons we're going to have is we take the mass number, which is going to be 12.011, and we subtract the number of neutrons that we just calculated, 6.011, and the answer that we get here is going to be 6 electrons. So I need to draw 6 electrons, but let me go ahead and erase the calculation just so it's out of our way. And we're going to have 6 electrons in this particular structure. And so we start off with the first orbital, and we're going to put 2 electrons in that particular orbital, which is the s orbital. And then we go to the second one, and so since we already got 2, we're going to have a remainder of 4 electrons in this outer orbital. And so since the electrons want to be as spread out as possible, in other words, they don't want to be touching each other at all. And so we're going to put them at opposite ends first. So there's 4, 5, and then 6. So that would be the structure of carbon. All right, let's go ahead and take another example here. Oh, I don't know. Let's go ahead and pick a metallic element, and let's go ahead and take magnesium, for example. And so let me go ahead and clear the screen. And if I look at magnesium on the periodic table, and I find it, normally I'll find it using its name, but I know that its symbol is going to be Mg. So I can go onto the periodic table, look at it there, and I'm going to find that magnesium is going to have an atomic number of 12, and it's going to have a mass number of 24.3050. And essentially, these are the 2 numbers that I need. So the first one, just again to remind us, this here is going to be the atomic number, which is also the number of protons that are going to be in this particular element, and this number down here is the mass number. Okay? And so let's begin with the first step. Let's go ahead and just calculate how many neutrons we're going to have. And so if I go ahead and take the mass number, which is going to be, and let me write the equation one more time. So I take the mass number, and I subtract from it the atomic number, okay, if I do that, that's going to give me the number of neutrons. Okay, and so in order to do that, then let's go ahead and fill in, use the numbers now and substitute here. The mass number here is going to be 24.3050. I'm going to subtract from that number, I'm going to subtract 12. And so when I go ahead and do that math, I come up with 12.305 neutrons. Right? So we really can't have 0.305 because these are going to be whole numbers. So the number of neutrons here is going to be 12 neutrons. Right? So that's part of the equation. The other thing that we need to calculate at this point is we need to calculate the number of electrons. So in order to do that, we've got to go back to a different equation. And the number of electrons, I'm going to go ahead and write it down here on the lower left corner. And we're going to have to take the mass number of 24.3050 and subtract from it the number of neutrons that we just calculated. Now, if I use the original number, the 12.305, then it's really easy. From there, 50, because it gives me a whole number, because these cancel out, and essentially I'm going to be left here with 12 electrons. And those are the two pieces of information that I need in order to get started with the actual structure of magnesium. So let's go ahead and start with our number of protons. So we have 12 protons, so I'm going to go ahead and draw them here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then I also have 12 neutrons. Change colors. I'm going to do my neutrons in blue. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? And now let's go ahead and draw our electrons. And we already calculated the number of electrons. The number of electrons is 12. So we begin with the first orbital, and then we've got 1, 2, go on to the second orbital, and it's going to go 3, 4, 5, 6, 7, 8, 9, 10. Then it goes to the next orbital, and they want to be as opposite as possible, so we're going to put them on either end. And that'll be a total of 12 electrons on the other shell, and this would be the structure of magnesium. So those are just two examples, and you can repeat these with all the others, and I encourage you to do so. Go ahead and try another one out on your own, and as you keep on doing more and more, that's going to allow you then to be very confident in drawing structures that are very essential. And just so that we're familiar with it, this particular structure that we're drawing here is called the Bohr structure, B-O-H-R, after Niels Bohr, the scientist who kind of developed the overall structure. But essentially, this is the structure we're talking about. And so practice, practice, practice. The more you practice, the better you're going to get at this. Okay? So that's all for this lesson. See you at the next one. Go ahead and subscribe us, and we'll see you soon.